So hello, today I am going to discuss about mission Chandrayaan-3. But before that, I need to give a brief overview of India's space program. For that, one person's name should be specifically mentioned. The name we all know is called father of space research in India. His name is Dr. Vikram Sarabhai. So, father of India's space program was the person, and ISRO was not the name of India's space organization from its inception. The name of it was when it was established by Dr. Homi Jahangir Bhabha, the father of atomic program in 1962. He made this person, Dr. Vikram Sarabhai, as the chairman of this body. And firstly, this INCOSPAR was placed under the Department of Atomic Energy. So let us look what Vikram Sarabhai said about India's space program. There are many who question about the relevance of space activities in a developing nation like India. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nation in the exploration of the moon or planets or manned space flight. At that time, in 1957, Sputnik was already launched. And then the then Prime Minister of India, Jawaharlal Nehru, made a contribution and took specific steps in the scientific advancement of space research in India. So we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems and man and society. So ISRO was established in 1969. 1969 is the year when ISRO got established, and the name changed from INCOSPAR to ISRO, and it was established under Department of Space in 1972. So after this brief overview on the India's space program's history, we should move to the discussion of our today's topic, Chandrayaan-3. So a giant leap. Why it is a giant leap we have to discuss today. Why it is called a giant leap for India's space journey. So why it is important to study the moon? In a cataclysmic event, some 60 to 175 million years after the birth of solar system and 4.5 billion years ago, a Mars-sized planet called Theia collided with Earth, and due to that collision, debris from this event formed moon. So there is a relation of the topography of moon with the earth. The collision with Theia likely transported some lighter elements like water. So that is why we are searching for water in the moon's surface. Because if earth had more water, then everything would be ocean and we would not have continents. So the water has been there in moon also, according to some scientific research of NASA and other space organization. Tides also played an important role in taking off the life on the earth. Those tides which are influenced under the gravitational force of sun and moon. Tides influenced by moon also likely help the ancient marine organisms move towards the land. And that's why we can connect why the study of moon is important, because it's like a part of earth from its beginning day. After that, we need to focus how does moon impact on earth's climate. Over 18.5 years, moon's orbital tilt relative to earth's equatorial plane, moon's orbital tilt relative to earth's equatorial plane either increases or decreases by 5.1 degrees, and this is called lunar nodal cycle. So you have to be specifically remember this term, lunar nodal cycle. What is lunar nodal cycle? Moon's orbital tilt relative to Earth's equatorial plane either increases or decreases by 5.1 degree over 18.5 years. This is called lunar nodal cycle. So when lunar orbit is aligned with Earth's equator, tides are stronger due to high gravitational force, and when it is tilted away from equator, the opposite thing happens and tides are weaker at that point of time. Sea levels also fluctuate with tides. NASA says, according to NASA, daily tides are intensified in one half of the lunar nodal cycle, and during this period high tides get higher and low tides get lower. So it is extreme situation, and daily tides are intensified in this one half of lunar nodal cycle, and in the another half of lunar nodal cycle the tides are not so much extreme, means high tides are not so much high and low tides are not so much low. The world will see global cooling due to lunar nodal cycle in mid 2020s. So there will be a global cooling, and you know the temperature of oceans also varies due to this tide event. Okay, because of tides the water circulates also, water circulation also happens, oceanic currents are also impacted by this event. So there is a relation with global warming and cooling and climatic events of the world with this lunar nodal cycle and tides. So the world will see global cooling due to lunar nodal cycle in mid 2020s and global warming in early 2030s. NASA is saying that in mid 2030 every US coast will experience rapidly increasing high tide floods, when a lunar cycle will amplify rising sea levels caused by climate change. So there is a relation of climate change of climatic conditions or global warming or global cooling with moon. So that's why the study of moon is important, and maybe in future missions we are going to study that relation, we are going to study that climate effect of moon on the earth. Okay, so let's now focus on Chandrayaan. This is why moon is important to study, and now let's focus on Chandrayaan. But before that, we need to know how tough it is to land on the moon. So data shows that historically over 40% of moon missions have failed. 40% of moon missions have failed. If we consider only those missions which involved a robotic lander, what is lander? Lander is basically a spacecraft which is performing a control landing on the lunar surface. Lander means what is landing on the moon surface. Okay, and there is another term called rover, which is roving around, means which is moving around and taking certain samples and making few experiments and giving us new data from the surface of the celestial body. Maybe it be moon or may it be Mars, anything. So that is rover, lander, rover. And one also thing is there, that is called orbiter. Orbiter mission means that in that mission one satellite is going to orbit the celestial body and not landing on the body. Okay, and there is also a mission called flyby mission. Flyby mission means just passing by that celestial body, be it Mars, be it moon or anything, any celestial body, just passing by that celestial body, that is called flyby mission, and taking some image of that celestial body. So this was the basic concepts, and so I just said that 40% of moon missions have failed. Okay, the failure rate sharply increases to over 60%, which missions there is a robotic lander involved. So when lander is involved, the failure rate also increases rapidly. Okay, and the failure rates of sample return mission, which collect samples from the moon and bring them back to the earth, it is even higher at 67%, and such missions are complex and riskier because you have to come back to the earth. Okay, and you have to bring the whole system back to the earth. That's why it is more complex, that's why it is more riskier. Okay, in September 2019, the Vikram lander of Chandrayaan-3 mission lost contact with the earth and went blank minutes before the lunar touchdown. Okay, so that was the failure, that was failed mission, but we learned from the failure and have recently launched Chandrayaan-3. Let's make hope that this Chandrayaan-3 will be successful. Okay, so the mission of lander and the rover Pragyan, what is the rover? That rover is called Pragyan rover, was declared a failure after that. The orbiter mission was a success as the orbiter was placed in the intended orbit. So this part was successful, but the lander and rover, these two parts basically was declared failure. Okay, so this is the story basically. Next we will come to Chandrayaan-1, India's first attempt to launch a satellite, to launch a mission, to begin with a mission on moon. That was Chandrayaan-1 in October 2008 with PSLV. Okay, the rocket carried a lunar orbiter, meant it has to go around the moon like a satellite, and an impact probe. What is an impact probe? Basically, impact probe has to hit the surface of the some region of moon. Basically, it was designed to south polar region of the moon to generate data relevant to designing a lunar rover that would be a part of payload in a subsequent mission. Okay, so we got an idea from this mission that availability of water molecules on the moon. That idea we got from this Chandrayaan-3, which was internationally acknowledged and also acknowledged by NASA. Okay, so the mission did not last 2 years as planned, possibly due to overheating issues in the orbiter, but it achieved most of the scientific objectives of itself, so it can be declared, or it was then declared as a successful mission. Okay, so what did the impactor probe do? Impactor probe collected information on the chemical composition of the lunar atmosphere. So that's the story of Chandrayaan-1. After that, I am going to Chandrayaan-2. Chandrayaan-2, in case of Chandrayaan-2, which was launched in which is launched in July of 2019, GSLV was used. GSLV was used. What is PSLV and what is GSLV? All these things I will discuss in a later video. So its payload included a moon lander that carried a rover to release on the moon, Vikram lander and Pragyan rover. Okay, the lander unfortunately crashed on the lunar surface due to software glitch, and the rover did not detach from the lander, and so the further studies on the moon surface were made impossible. So that's the story. Because of software glitch and because of all these things, lander got crashed, and rover also did not detach from the lander. That's why the mission was declared as failed mission. Lesson learned from the Chandrayaan-2 helped to avoid design deficiencies that are likely to contribute some failures in case of Chandrayaan-3. Some upgrades has taken place in case of Chandrayaan-3, which include the strengthened legs of the Vikram lander and software updated to avoid that software glitch situation which happened in case of Chandrayaan-2. Okay, so this was the story of Chandrayaan-2. Now come to Chandrayaan-3. The mission is a joint project between ISRO and India's private sector. So it was the first mission in India where private sector cooperated with the government chief space agency, that is ISRO. In case of US, this thing already happened 2-3 years back, but in case of India, it's the first time the Indian private sector collaborated with ISRO. Okay, and it demonstrates government's commitment to the new space policy. The new space policy is released in 2023 only, that states that India's space program should enable, encourage and develop a flourishing commercial presence in space. So you may question me that why the private sector's participation is so much important. Because when private sector participates in any country's space research and space program, then the more funds will come in case of space development, in case of space research. Okay, and if private sector collaborates, then also it encourage and develop, as the space policy of 2023 states, the commercial space in case of India. And India, ISRO is already famous for launching satellites, from by using its own launcher, using its own launch pads. Okay, so India is famous for that, ISRO is famous for that. Okay, so there are bodies like Indian ISPA, Indian Space Agency. Okay, there is body like Antriksh. Okay, all these body we'll discuss in a later video. Okay, so the lander of the mission will land at a latitude of 70 degree south, close to the South Pole. So India is going to discover or going to gather some data from the South Pole. And now a question will automatically arise in your mind that why South Pole is so important. Okay, so South Pole is important because there are many geographical variation on the surface of the moon. As you all know, the southern hemisphere has many high mountains and deep craters which are more extreme in nature than those in the north. Okay, and there are large areas which are permanently shadows near the poles where temperature can go up to minus 200 degrees Celsius. So that's the part of the moon which is till now unexplored part of the moon. So that's why ISRO is too much interested to go there to land in the South Pole, near the South Pole. Okay, these are home to many volatiles which are chemical components or compounds that melt or vaporize at moderately warm temperature. That includes water, which we suspect exist in large quantities in supercooled ice form. So as we have discussed earlier that water should have been there in the South Pole of the moon, maybe in supercooled ice form because it is minus 200 degrees Celsius. Okay, so water might be found in the South Pole area of the moon. This volatile substance could provide valuable insights to the history of the solar system. We can know a lot of things from the history, from the research, from the mission about the history of solar system and about the birth of the solar system also. A fossil record of early solar system can also be found in coal trap craters near the South Pole. So that's why going to the South Pole and taking samples from there is very, very important for scientific community and new research. Okay, so the significance of Chandrayaan-3, if it succeeds with the moon landing in August, India will only become the 4th country to have done so after US, Russia and China. Okay, so a successful mission will be a major flip for the space agency as it prepares for another tough enterprise, that is Gaganyaan mission. Gaganyaan mission will be India's first manned space mission. Okay, that is going to be launched in the end of 23 or 2024 to space. Okay, the work is going on in this area, Gaganyaan mission. The mission is a major step towards India's lunar exploration program, and India is sure to make, India is going to make significant contribution to the understanding of moon. That's why it is taking this new mission. Okay, so and also its contribution in understanding of the moon will grow its own value in the international community. Perhaps more importantly, it will showcase India's capability and build its reputation. Whatever I was saying previously, that its own reputation will be built in global space community, which will help attract more investment in the country's own space industry. Space industry can gather investment from foreign, that is called FDI, FPI, and many private bodies, many private agencies can show its own interest in this sector. Okay, so that's why it is important. Next, we should discuss about the cost of Chandrayaan-3. People often ask that a poor country like India cannot afford to spend rupees 600 crore on a mission on moon, because India is after all, India is not so much rich country. It comes under the list of developing country. So we don't have so much fund. People think, as a people acknowledge in themselves that Chandrayaan-3 is a huge cost. Chandrayaan-3 must be a huge cost over the economy of India. So the amount, if we consider that rupees 600 crore, the amount is even less than the budget of some major movies. Okay, and 1/5 of the price of the single Boeing 747 aircraft. This is of USA. Okay, it opens collateral possibilities for the country and local industry to earn far more in associated projects, thereby contributes to the economy too. Okay, so more and more youth will be involved. More and more youth, more and more industries will be involved in associated projects. So thereby it is hopeful. India is hopeful there will be contribution in our economy from this. So it can never be said that we are wasting our money in case of space missions or in case of lunar missions like Chandrayaan-3. The success of Chandrayaan-3 will send a message to young people across the country that it is possible to do quality scientific research, and make difference here on Indian soil. India can also make scientific contribution. India can also it is also possible for India to make difference in science, in research. That's all the things which can be proved by this mission. So it is totally useless to put a price tag on Chandrayaan-3 after knowing its significance, because the contribution it's going to have on the young generation, on the scientific community, it's immense. So that's why it's totally useless, I think, to put a price tag on Chandrayaan-3. So that's all which I wanted to discuss today about Chandrayaan-3 and India's space odyssey. So now I want to end my session. Thank you for watching the session. Please like and subscribe my channel if you like this video and like my initiative. Thank you.